Okay, we have the test 14 study guide. Our first job is to convert 80 cubic yards to cubic inches. If you recall, when you look at some unit given to you, in this case 80 cubic yards, we put that over 1. Remember, the unit of yards is being cubed. The number 80 itself is not. It's to the first power. And the fact that we're going to use here is that 1 yard is equal to 36 inches. That's only inches in yards, not cubic yards. Since yards is currently located in the numerator, I put a yards in the denominator for cancellation purposes. I put inches in the numerator, and the facts are that 1 yard and 36 inches are equal. So make sure 1 goes to yard and 36 goes to inches. Since this is cubic yards and this is only yards, I need to cube my multiplier. Now this is cubic yards, this is also cubic yards. Everything else inside that parentheses is cubed also. At this point, it does say cubic inches, so I'm at the right unit inches cubed here. So to get the answer, I'm simply going to take the 80, which again is just 80, it's not 80 to the third power, it's just 80. We're going to multiply that by 36 to the third power. If we type that in, 80 times 36 to the third power comes out to 3732480. 3,732,480. If you're not sure how to use the power button on your calculator, the other option would be 80 times 36 times 36 times 36. That's equivalent to 36 to the third power. But again, pay close attention. That's 180, 336s. Number 2, represent the following numbers as being members of set K. Now keep in mind, I'm very, very particular about how this is written. It does say set K, so I'm going to start there. Capital K equals. It has to be an equal sign. Then I use some sort of set bracket. I'm fine with a square bracket that's easier to draw. At this point, I'm going to list every number that happens in numerical order 1 time per number. Even though 0 happens a lot of times, I'm going to write 0 once. The next biggest number is 2, and then 3, and then 4, and then 5, and then 6, and then 7. I want to make sure I get every single number. If you leave a single number off, it's wrong. You don't put them in numerical order, it's wrong. You don't put commas between the number, it's wrong. It must be in set brackets. Again, the letter they chose, whatever it is, equal sign, set brackets, every number in numerical order, commas in between each one. Don't leave any numbers off. It's an easy problem, but people miss it because of carelessness. Be careful that you do it correctly. Number 3, I'm going to give you a set, and I want you to write a true statement using the element symbol, or I might say write a false statement. It'll say something, true or false. Just make sure the statement you write is either true if it asks for true, false if it asks for false. And it only asks for the element symbol, so I'm not looking for the negated one, the slashed one. So, the proper way to write something with an element symbol is some number is an element of some set. That's how you write it. So what I want to do here, here's my element symbol. I take any one of these numbers, take your pick, 10, 11, 12, 13, 14, is an element of that set name. It'll be just that easy on the test. If it asks for a false statement, 9. All right, that's the true one. 9 element of A is false. Or take your pick, any number that isn't these 5 numbers would be fine. So if it asks for a true statement, there's a true statement. If it asks for a false statement, there's a false statement. In my opinion, that's a free 7 points on the test. Prepare well, and you should be fine. Number 4. Some of you are having difficulty with this type of problem. Some number is some percent of some number. Start the percent proportion. It's simply a proportion, fraction equals fraction structure with 100 in the bottom. Always do percent first. 150%, percent always lives right above 100. And then the only words we have left are is and of. Is only next to what number, and of is only next to 50. Okay, this is over of. So, what number is unknown? Of 50, 50. So there's how you set the proportion up. Once you get the proportion created, this product, 100 times x, equals that product, 50 times 150, which is 7,500. Then we simply divide both sides by 100. Get x equals 75. I may put a number here, put a what percent, put a number there. I could put number, percent, and what. So again, it's just a matter of getting everything where it belongs. Percent goes first over 100, is on top of on bottom. Anytime it says what, that represents an unknown. So make sure you use an x to represent it. Once you get the proportion created, cross, multiply, solve the remaining equation. Number 5, write a conjunction that describes this graph. Once again, in my opinion, this is a free 7 points. There's no reason anybody should miss this problem. It goes like this. Start with 2 less than symbols. Doesn't matter what you're looking at. If you see dot, shade between dot, it's going to be less than symbols every time. And any letter you wish goes in the middle. It doesn't matter what letter you pick. I like X. The smallest number that has a dot is going to go on the left-hand side. The biggest number that has a dot goes on the right-hand side. And then finally, open circle, you're done. Closed circle, you got to put an equals to. There's the answer. No reason anybody should miss that. It's very, very simple. Simply do what you're supposed to do. Less than, x less than, start there. Smallest number on the left, biggest number on the right, closed circle gets you an equals. Number 6. The challenge of this problem and problems of this variety is going to be the simplification. So take your time in that step or steps. -2 times -3 is +6. -2 times +4x is -8x. Keep in mind when you distribute, the sign and the number are being multiplied through. Next we have -4 squared. That's going to be -16. 4 is being squared. The minus sign is not. Next we have minus absolute value of -5. This part here is equal to 5. The absolute value bars make the minus sign go away. This minus sign happens after the bars, so it stays negative. It's tempting to negatives make a positive kind of idea that you've seen quite often. Absolute value bars take precedent over that. So the absolute value bars made the +5. The minus sign moved down after that. Equals is just equals. And then we have another simple distributive property here. This is a minus sign distributing through this parentheses. Again, that minus is going to subtract both things. Minus this -7x makes +7x, and minus that -7 makes +7. Okay. If you make it through that step correctly, the next step is simplification by adding like terms. On the left-hand side of the equal sign, I got 6 minus 16 minus 5 are like terms. 6 minus 16 is -10, minus 5 is -15. Minus 8x has no like terms on the left-hand side, nothing happens to it. Equals stays equals. On the right-hand side I have a 7x plus 7. Nothing's happening to that side since there's no like terms on that side. Okay? So the only thing that changed was the fact that we have 3 numbers. 6 minus 16, -10 minus 5, -15. At this point I've got x's on both sides, numbers on both sides. It's your decision which side you want things to go to. I'm going to move the 8x, which is negative. I'm going to move it to the right-hand side, so plus 8x. Since the x's are going on the right-hand side, I'm going to take the +7, move it to the left, makes it -7. Changing signs of things that move. Negative became positive, positive became negative. I add or subtract based on the signs I'm looking at. These signs are the same, so I add. 15 is bigger, so it's negative. These signs are the same, so I add. 8 is bigger, so it's positive. So -22 is equal to 15x. Last step, always divide by the number in front of x. The coefficient of x is what it's called. In this case, 15 times x, division by 15 is going to solve it. So -22/15 will be the right answer. Chances are that'll come out to a fraction type answer on the test too, since the one on the study guide did. If it happens to come out to a nice whole number integer, just count yourself as lucky. Reduce the fraction if possible, but doesn't reduce. Number 7. I'm going to evaluate this. So -x minus 2 is equal to 5. I'm going to solve for this actually. So -x minus 2 is equal to 5. I'm going to move the 2 over, so plus 2. That gives me -x is equal to +7. Changing both signs gives me x equals -7. So this is the value of x that goes up here. And then I have a plus 3 is equal to 4. going to solve that also. Move the 3 over, subtract. I'm going to get a is equal to 1. That's the value of a. That's what's going to go right there. And I probably should circle it better here. We're going to change this x to a -7. Now, if you take a look at the expression we're trying to evaluate, which is this, it says find the value of. All right, x squared minus 2 times a. Keep in mind that when you square a letter, you're going to square its value. Its value contains not just a numerical value, but also a sign. So x is equal to -7. -7 goes in this parentheses. A is equal to +1. +1 goes in that parentheses. Evaluating -7 times itself makes +49. Keep in mind, x is being squared. The minus sign is being squared. The 7 is being squared. 2 negatives make a positive. 7 times 7 is 49. 2 times 1 makes 2, so it'll be -2. And then finally, 49 minus 2 is equal to 47. So that's the answer to that one. Find x, find a, substitute, simplify correctly. Number 8. Simplification of a complex fraction with a fractional numerator and a fractional denominator requires us first to find the main fraction bar. This one's a little bit longer, a little bit bolder than these two, making that the main fraction bar. So I have a fraction on top, I have a fraction on the bottom. I look for the least common denominator of the two fractions, which is x times y. So here's my main fraction bar. I want to multiply the top of the fraction by xy. I want to multiply the bottom of the fraction times xy. This xy that I'm multiplying by officially is over 1 on top, and it's officially over 1 on the bottom. That establishes position. So on top, I've got an x on top, I've got an x on bottom, x's cancel, b times y is left over. On bottom I have a y on top and a y on bottom. This y cancels that y. I've got an ax left over. And again, your main fraction bar separates them. That's the simplest answer, by over ax. Number 9, solving a system of equations with substitution, which is the technique we've learned so far. And this right here tells me that x is the same as y plus 1, and up here I have an x. So my first task is to change this x up here, right here, into this expression y plus 1. So 3 times x becomes 3 times y plus 1. That's what this piece is. And then plus 2y is just plus 2y. And then equals 23 is just equals 23. So the top equation is exactly what it was. 3 times x, though, changed to 3 times y plus 1. Replace x with x's equivalent expression. One object got changed to 2 objects, so parentheses happen. Plus 2y stayed plus 2y equals 23 stays equals 23. The remaining equation I have here has only y's in it, so if I distribute 3, I get 3y plus 3 plus 2y equals 23. This has a y, this has a y, this doesn't, so I'm going to take the 3 to the other side and subtract it. 3y plus 2y makes 5y, 23 minus 3 makes 20. And if I divide both sides by 5, I end up with y is equal to 4. Once I know what y equals, I go back to my substituting equation that says x equals y plus 1. That's what this says. Y is equal to 4, so x equals 4 plus 1, because again we found out y equaled 4. Change this y into a 4. 4 plus 1 is 5. Once you know both x and y, we write an ordered pair. X goes first, y goes second. Expect nice integer answers. I'm not going to give you one that has fraction answers. So if you get fractions, let's say that maybe you did plus 3 here, all of a sudden you get 26 over 5. You did something wrong. Check your work. Number 10, same type of problem, just doing it the same way we did the last one. This one says y equals everything else. So I'm going to take this x plus 4, which is the same as y. I'm going to take this y out. I'm going to put x minus 4 in. So 2 times x minus 3 times y is equal to 6. But instead of writing 3y, I write 3 times x minus 4. Again, replacing one object y with multiple objects x minus 4, put parentheses around it. This time we have a minus sign in front of our parentheses, so when I'm distributing, I am distributing a -3. So 2x stays 2x, equals 6 stays equals 6. Distributing the -3 gets me -3x, and minus 3 and minus 4 make plus 12. And again, be very cautious of signs in the process of getting the answers. Hate for anybody to know what they're doing and they get a wrong answer because they weren't thinking through the multiplication. At this point, I've got x's on the left, so this 12 needs to move over. It's plus 12 here, so minus 12 over there. 2x minus 3x makes negative 1x. 6 minus 12 makes negative 6. We always want to know what x equals, so if we have negative x equals, that means positive x equals the opposite sign. So change the sign, that's the value of x. Once I know what x is, right up here it says y is equal to x minus 4. I'm going to change x into 6 because that's what x equals. 6 minus 4 is equal to 2. And once I have both x and y, again we write our answers in ordered pair, x first, y second. Number 11, graphing. Okay, to do graphing, as of right now, we haven't learned any method except for the xy table. In order to get an xy table, the first thing I want to do is get y equals. So I'm going to take anything that isn't y and move it to the other side. So 2y stays on the left, 6 stays on the right, both of those staying where they are, stay the same sign. 3x moves across, becomes minus 3x. That's 2y equals. I want to get y equals, so job 2 is to divide by 2. So I'm going to divide this by 2, which requires me to divide everything by 2. And I do recommend an individual term division, so divide, divide, divide. Every single term divides evenly or leaves a fraction. So 2y over 2, the 2's cancel, leaving y. 6 over 2 divides out to 3. And again, 3x over 2 doesn't divide evenly, so I just leave it as 3x over 2. The x does live in the numerator, so make sure that you write it in such a way as the x is in the numerator. And as far as picking x's here, you're allowed to pick anything you want to. My recommendation in a situation like this where there's a fraction, if you pick numbers that divide by 2 evenly, it makes the job easier. So I'm going to go with 0, 2, and 4. I could have picked negative 2, negative 4. If you like negatives better, it doesn't matter what you pick. If I start with 0, let me use a different color here, 0, y is going to equal 3 minus 3 times 0 over 2. Again, I'm just replacing this x with that number to figure out what y equals. 3 times 0 is 0 over 2 is 0, and 3 minus 0 is equal to 3. So 0 goes into the equation, 3 comes out of the equation. Next number I have is a positive 2. Do this one in red. So again, I'm replacing this x with a positive 2, so y is going to equal 3 minus 3 times 2 over 2. The 2's cancel, that's just 3 minus 3, and 3 minus 3 is equal to 0. So I put a 2 into the equation, I got a 0 out of the equation, so 2 goes in, 0 comes out. Final number I have here for x is 4. Do this one in green. So y equals 3 minus 3 times 4 over 2. 3 times 4 is 12, over 2 is 6. And 3 minus 6 is negative 3. So I put 4 into the equation, I work it out, and negative 3 comes out of the equation. So again, x, your input is anything you want it to be, the output is whatever the equation tells you it is based on the order of operations. And once you get inputs and outputs, you simply plot those points. So 0, positive 3 goes right there. We go 0 left to right, 3 up. 2, 0 is 2 to the right and 0 up or down. And 4, negative 3 is 4 to the right and 3 down. If you do it correctly, the 3 points should line up in a nice straight line, which they do. We connect that with a straight line. We always make sure we put arrows on the ends of our straight line. Let me just highlight that a little bit. We can see the arrows well. So all 3 lines, all the 3 points lined up nicely. Straight line, arrows. Use a straight edge when you draw lines. Number 12. This problem has 3 parts to it. It says to add, write the answer in descending order of the variable. Notice x squared, x constant, x squared, x constant, x squared, x constant. Each one of the pieces is already in descending order, so the descending order is going to work itself out. What I need to do is distribute correctly and then simplify by adding or subtracting based on sign. So this part of it, 5 times each piece. Again, and mentally think the words positive and negative when you do these multiplications. So positive 5 times positive x squared makes positive 5x squared. Positive 5 times negative 2x makes negative 10x. Positive 5 times positive 1 makes positive 5. Okay? 2 positives make a positive. Positive times negative makes a negative. The second one, once again, we got a distributed property having the negative number attached. So this is negative 4 multiplied by each object. And again, mentally think negative as you're multiplying it out. Negative 4 times positive 2x squared, opposite sign is going to be a negative 8x squared. Negative 4 times negative 3x, two negatives make a positive 12x. Negative 4 times negative 5, two negatives make a positive 20. Each number gets multiplied by 4, and then minus sign changes the signs from plus minus minus to minus plus plus. The last one has nothing in front of it, it's just a parentheses, plus parentheses. So basically we're distributing a plus sign through. Plus positive x squared is plus x squared. Plus negative 3x is minus 3x. And plus positive 5 is plus 5. And I would recommend, and again, this is up to you individually how you want to do this, I'd recommend putting a 1 anytime there's no coefficient, any letter with no number in front of it, just to really reinforce that there's a number there. And then it's just add like terms. 5 minus 8 is negative 3 plus 1 is negative 2. That's x squared. Negative 10 plus 12 is 2. 2 minus 3 is negative 1x. The 1 is optional there. You can put minus x, means the same thing. 5 and 20 is 25 plus 5 is 30. Everything's positive, so everything just adds together. X squared, x constant, ascending order is there. Everything's done. That is the extent of that problem. It should look very similar to that. I think even you can anticipate the middle one's going to be the negative 1. So just be cautious with the distributive property that you carry the negative through the multiplication on that middle one. Number 13, multiply. Right answer in descending order of the variable. Now, we'll multiply first. 6 minus x squared means 6 minus x times itself. So 6 minus x times 6 minus x. When you have a binomial times a binomial, I'll give you 3 different ways to do this. I'm going to go with the distributive property way. The distributive property way says we take this object, whatever it is, times the entire second parentheses. 6 times 6 is positive 36. 6 times negative x is negative 6x. Then I take the second object, which is negative x, the minus signs included, times the entire second parentheses. Negative x times 6 is negative 6x. I'm lining up like terms. Negative x times negative x makes positive x squared. Be careful, it's x squared, not 2x. When you multiply x's, you add powers. If I add straight down, 36 has no like terms. Negative 6x and negative 6x, same sign. I'm going to add, I get negative 12x and then plus x squared. That's the correct answer in ascending order. Descending means stepping down. Ascending means stepping up. Smallest power, next biggest, next biggest. I want to rearrange it so it's in descending order. That's the correct answer in the correct order. And I will give it in the wrong order here, so you'll have to rearrange it. It's real simple. There's no equal sign here, so I'm not changing signs to do this. This goes in front, it's positive. This goes in the middle, it's negative. This goes last, it's positive. Make sure pluses happen after the first term. Positive number in front doesn't need a plus sign. But this is in front, it needs a plus sign once I put it after the 12x. Make sure that when you rearrange it, any necessary plus signs show up. If you give me this answer, not in descending order, you'll get half credit. I mean, it's still right, it's just not in the right order. So have that on your paper just in case you mess up on this. I'll still give you the half credit for having the ascending order answer correct. Number 14, find the area of the figure in square centimeters. And notice it's in italics, it's bold, so it kind of gives you a hint, hey, something's going on here. And what you're supposed to notice is that this is centimeters, which is good. This is also centimeters, good. This is not centimeters. 0.6 meters times 100 centimeters in a meter. And that's our fact that 100 centimeters is equal to 1 meter. Same fact we usually use when we're converting. Unit of meter on top, unit of meter on bottom cancel. 0.6 times 100 is equal to 60 centimeters. So rather than 0.6 meters, we want 60 centimeters down here. Make sure you convert all the units so everything is centimeters. And these area of a trapezoid, which is what this is equal to 1/2 times the sum of the bases times the height. The bases are the parallel sides. So 24 and 18 we can see are straight up and down parallel to each other. So if I add these up, that makes 42. That's one of the numbers that goes here. The other number is how far apart are they, which is 60. So 1/2 times 42 times 60, and half of 42 is 21. And 21 times 60 is 1,260. That'll be centimeters squared. If you do not convert that 0.6, you'll be off by, you'll get 12.6 instead of 1,260. You'll be wrong. So be careful that all these units change to centimeters, because that's what they're asking for the answer to be in, square centimeters. If you don't want to use the trapezoid area formula, the other option, again, this is still 60 centimeters, that hasn't changed. If I were to draw a dashed line across here like so, the bottom half is a rectangle, the top half is a triangle. And what you have to realize is that's 18, so is this. And if this is 24, this must be 6. And if this is 60, this must be 60. So you got your triangle part, the top part, which is here, equals 1/2 times the base 60 times the height 6. Half of 60 is 30 times 6 is 180. And then you got your rectangle part, which is right here, which is 18 times 60, which is 1,080. If you take 180, the area of the triangle, add it to 1,080, the area of the rectangle, you get 1,260 centimeters squared. To me, that's a lot more clumsy, but if you don't remember that formula, rectangle, triangle will be two formulas that you should remember from like 4th or 5th grade. So I recommend learning this one, becoming familiar with it. But again, this technique will work for the sake of the test. Finally, number 15, once again we have a trapezoid. It says a base of the right solid 14 meters high is shown, find the volume. Anytime you see the words find the volume, volume equals area of base times height. The two numbers I want to find are area, base, and height. And it does tell me very clearly 14 meters high the right solid is. That's where the height of the solid is going to be. It's not going to be over in the picture. This is the base over here. The base is once again a trapezoid. So again, if we use our really efficient formula here, area of the base is going to be 1/2 times two numbers. One of those numbers is the sum of the parallel sides. 6 and 18 obviously are parallel to one another. 18 plus 6 is 24. The other number is how far apart they are, which is 10. 1/2 of 10 is 5, times 24 is 120. That's what number goes right there. And once I have both of these numbers, volume is simply the product of those two numbers, 120 times 14, which is 1,680 cubic meters. Just to verify, 120 times 14 comes out to 1,680. So that's right. Once again, if you want to do the more clumsy way, you can make a rectangle on the bottom, a triangle on top, add up the two areas. But again, whatever the area is, whatever this is that you found from this picture, it still has to multiply by the height of the solid to get the actual volume. Please do not stop here. Make sure you incorporate the height in order to find the volume, not just the area of the base.